afternoon, everyone. This is Soumen from Chemistry Department of Paira. So I'm going to teach you the lecture 5 and which belongs to the organic chemistry of basic and techniques. Okay. So in the previous lecture, what we have read or gone through, I'll just go quickly by the previous slide. So whatever we have discussed about the like inductive effect, then some of the what kind of inductive effect is there, plus I effect, minus I effect, and then resonance structure of the benzene rings. Then some of the two example we have already discussed in the previous lecture. One is the nitromethane, and another one is the benzene. And then we have discussed four question answer section and that part. And today we are going to the lecture 5, which belongs to the resonance effect, how the resonance effect works. Okay, so first, resonance effect. So what is actually resonance effect? So before going to the definition, I will tell you briefly about that what is actually the resonance effect. So resonance effect is saying, the first we go to the definition. The resonance effect. This resonance effect is defined as the polarity produced in the molecule by the interaction of two pi bonds. So polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons present on an adjacent atom. The effect is transmitted. The effect is transmitted through the chain. There are two types of resonance or mesomeric effect designated as a R or AM effect. Right. So the resonance effect is defined as the polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons present on an adjacent atom. This effect is transmitted through the chain. So it's going through a chain. Now there are two types of resonance or so resonance effect also in other way around we can also call as a mesomeric effect, and we can denote as a resonance effect. We can denote as a, so for purpose, even in some of the competitive exams people can also ask what is R. So resonance, so resonance resonance effect uh, is also known as a, is referred to. Okay, now the mesomeric effect. What is mesomeric effect? Now the mesomeric effect is actually AM effect. So it is also known as the AM measure. This is called AM effect. So now we'll discuss the example. So one example we'll discuss about. So actually the molecule is the CHO. Now it can be represented in such a way. So here one proton is here. This is highly acidic enough. Highly acidic. Why it is acidic? Because this proton is adjacent to the two aldehyde as well as the electron withdrawing in a NO2 group. Right? NO2 also electron withdrawing group. CHO, one CHO is here, another CHO is here. So now three electron withdrawing group present to that carbon, which carbon attached to a one hydrogen, it will be much more acidic compared to any other things, any other proton. So obviously this proton is highly acidic. Now if you write the structure, okay, so this is the three structure of the this molecule. If you see the molecule CH, CHO, CHO, NO2, now it will go for the enolization, like keto-enol tautomerization, but due to the acidic proton, so it will take this proton here and here, it will go to this form, structure 1. This is the actual molecule. Then it will go to structure 2, that is a keto-enol tautomerization. Why this form is stable? Because due to this kind of hydrogen bonding. So due to this kind of hydrogen bonding, it will get stabilized this form. Now again, so there is some possibility of this lone pair can come here. It will go and nitro group will much more. It will get stabilized with this nitro group. So this is the structure 3. So this 3 structure is possible for this molecule, where the CHO, if you see the molecule CHO and NO2. Okay, so this is the actual molecule. And also there are two types of resonance measurement effect designated as R or M effect. So so whatever in the definition they are saying, the molecule the produce in the molecule, you can see the resonance will be divided by the polarity produced. You can see the if it is the neutral molecule, then the polarity inducing produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electron. You can see there is a pi bond and pi bond rotation also is there. Pi bond and lone pair of the electron present on an adjacent atom. So interaction between this lone pair, interaction between interaction between this lone pair and pi electrons, pi bond and the lone pair of electrons present on an adjacent atom, and the effect is transmitted through the chain. You can see the through the whole chain, it is this effect is transmitted through the chain. Okay, now we'll go to the positive R effect, and as as I already discussed here, they are saying that there are two types of resonance effect or mesomeric effect, right? Now, what are the two resonance effect? We'll see. So, one is called as the positive resonance effect, or shortly we can also call it a Plaza effect, right? Shortly also we can say the plus R effect. Now, suppose it is a plus R effect. Why it is plus? You can see the name itself, it is saying the plus R or positive resonance effect. In this effect, transfer of electrons is transfer of electrons is away from an atom or substituents group attached to the substituent group attached to the conjugated system. So let's say first we'll discuss about the positive resonance effect. So then we'll come to the why the definition it's saying in this way. Okay, we'll discuss every single word. In this effect, the transfer of electrons is away from an atom is away. Electron is away from an atom or substituent group attached to the conjugated system. So that means electron is going through the whole system. Okay. Now we we have a system. We have a. I bring one example where they have clearly shown that how it works actually. Okay. Now now if you see the NH2 group is here, right? Aniline. This is called aniline. So if a simple example I say aniline, formula is C6H5 NH2. Or if you see the structure is look like. Okay. Now I bring this example. Will show the how the positive resonance effect works in this molecule. Okay. So positive electron means the electron is away from an atom or substituent group attached to the conjugated system. Conjugated mean what? Conjugated means there will be alternative double bond, like conjugated double bond. This is called alternative double bond is there. Suppose CH2, CH2. So two double bond alternative bond is there. So that is called conjugated. Conjugated. Now let's say if we have this NH2, now it is going. So this NH2, first we'll draw this compound, then we'll go one by one. Okay, this is the first structure. Now we'll go to the second structure. Now we'll go to the second structure. Okay, now we'll again rotate this one. So first structure to second structure, then it is a now second structure. Now we don't have space. We can erase this part. Okay. Now again we come back to the structure one. The structure five. Now again structure five to structure one. So this is called positive resonance effect. Okay. Now we'll go to the second part, because in the first slide, whatever we have discussed, they are saying that in the mechanic, in the definition they are saying. So there are two types of resonance effect. So one is positive resonance effect, this is plus R effect, and one is negative resonance effect, that is minus R effect. So we will discuss the what is negative resonance effect, right? So the effect is observed when the transfer of electron is towards the atom or substituent group attached to the conjugate system. Now in the previous slide we discussed what we discussed. In the previous slide, see the electron is going away from the atom or substituent group. See, this electron is going through whole the ring and again coming back. But here, negative R effect is what? The effect is observed when the transfer of electron is towards the atom or substituent group is attached to the conjugate system. That means any electron withdrawing group is present. So we know that any electron withdrawing group is present. That means it will means takes the electron to it attracts electron towards itself, right? So like the same way, if we see any kind of electron withdrawing group is present to the aromatic system, and the transfer of electron towards the atom or substituents group attached to the conjugate system, whether it is a benzene ring or non-benzene system, but there will be some resonance effect. So now we'll discuss this part. Okay, so in this part, so this is called actually, we know nitrobenzene, right? NO2 and pH. NO2 pH is what? NO2 and pH. That means NO2 pH is NO2 pH. First we'll write the structure pH NO2, and this is called nitrobenzene. This is called nitrobenzene. This is the structure of nitrobenzene, and this is also formula C6H5NO2. Okay. Now we'll discuss the this resonating structure. Let me first erase this part because this is we don't have much space. We can nitrobenzene, we can also write in this. So then this is the positive charge is generating here now. Okay, now so total there will be this structure, structure 1, structure 2, structure 3, and structure 4. Okay, so there is a good structure is possible for the negative hyperconjugation. Negative resonance effect. So negative resonance effect is when the transfer of electron is towards the atom or substituent group attached to the conjugate system. Then only it is called as a. Okay. So now just 1 minute. There is some mistake from my side. One bond will be not there. One bond will be not there. One will be not there. Now, okay. So now what will happen? Now this double bond will come back and it will come to the original. Oh, this is no, actually I'm not. I'm just taking this structure. Just 1 minute. No, 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 no. It's going. Hello. This is. I'm drawing this structure. I'm, I'm drawing this structure. Just 1 minute. So then, so this is the first structure of this nitrobenzene. Then this is the structure 1, 2. The again we will come back to the structure 1 here. You can see. So this is the negative resonance effect. So in case of nitrobenzene, if you see this NH2 is there, then that case the positive charge generated on the nitrogen atom. So that means electron is going away from the atom or substituent group attached to the conjugated system or any arene system. But in the case of negative hyperconjugation, negative resonance effect, the electron is coming towards the group attached to the conjugated system or Benionite system, or like any arranged group system. Okay. So before I'm drawing, because I'm drawing, why I'm drawing? Because if we don't draw this one, maybe it is not actually good for the audience to understand. So this structure, so how this structure to this structure come, then this structure to this structure come, and from here to here how it is coming. So that's why I'm drawing all the structures, and in between maybe my voice is not coming because I'm drawing this one. So what happened? So we start from the, so let's say this double bond it's going here, then this double bond is going minus, so o is now minus, then here as the double bond is going towards this double bond, so then there will be generation of the positive charge. Now this double bond is moved towards the this cc bond formation, then the positive charge will get saturated. Now here is a one double bond, another one is the, here is a another double bond. Now positive charge is here, negative charge is here. Now this O minus will come here, and then there will be a generation of this double bond. Now, then again we have this structure one. Okay. Now we'll go to the what are the group actually? So the plus R effect and the minus R effect. So plus R effect is the plus R resonance effect. So if you see any molecule conjugated system or arranged system contain halogen group or OH group or OR group or OCOR, that is for ester group. NH2 group, as only I have discussed this example with benzene and NH2 group. So it may be instead of NH2, there may be the these are the group can be present. So these are all group will show the plus R effect, and NHR and NR2 and then NHCOR. That is called the plus R effect. Now minus R effect. What is minus R effect? So COOH, CHO, carbonyl, CN, and nitro. Right. So this is the all carboxylic acid group and CHO group and carbonyl group, CN group, and NO2 group. These are the group will, if somewhere it is attached in the arene room or arene ring or a conjugated system, then it will show the minus R effect. Now coming to the what is the electromeric effect. So what is electromeric effect? Now you understand fully what is plus R effect, what is minus R effect, what is resonance effect, right? Now the electromeric effect. So what is electromeric effect? So it is actually temporary effect, right? So what is actually temporary effect? The organic compound having multiple bond show this effect in the presence of an attacking reagent, in the presence of an attacking reagent only. So it is defined as the complete transfer of a shared pair of electrons to one of the atoms joined by a multiple bond on the demand of an attacking reagent. So it is represented by E. So what is electromeric effect? So it is a temporary effect. The organic compound having multiple bond show this effect in the presence of an attacking reagent only. So it is defined as the complete transfer of a shared pair of pi electron to one of the atoms joined by a multiple bond on the demand of an attacking reagent. It is represented by E. So this is important. So electromagnetic effect is represented by E. Now we'll go to the, so like the resonance effect the same way. Electromagnetic effect also, two types of electromagnetic effects are there in chemistry. So one is the plus effect. So first we'll discuss the what is plus effect. So in this context, in this effect, the pi electrons of the multiple bonds are transferred to that atom to which get the reagent gets attached. Now the electron will go. Suppose let's say we have a one positive charge that is called the proton. This is called actually proton. When you see anywhere proton, that is H plus. If you see hydrogen, that means H. Okay. Now let's say this double bond electron density, how it works actually. If you see the double bond electron density, it remains in this way. There is a some electron density like this one. So actually, I am when I am drawing now. Actually, I am not talking much because after drawing I will talk. So that is called the minus. So let's say here one carbon is there, one carbon is here. So one hydrogen, hydrogen, and one hydrogen, hydrogen. Now, if the electron density is going here, now what will happen? So there is positive charge, right? So there is a positive charge and there is a negative charge because if the whole electron density going to one atom, then there will be definitely generation of the positive charge. So now let's say we have a proton H plus. Now we have a negative and positive. Obviously, negative and positive has there some attraction. So then it will take this proton from here. Now you can see. So what will generate? So first we start from here. We start from here, and now we have intermediate state is this one. Now again after addition of H plus, what we'll get? We'll get this molecule. Here is a positive charge. Okay. So this is called plus E effect. So transfer to the atom, multi pi electrons of the multiple bonds are transferred to that atoms to which the reagent gets attached. Okay. So proton H plus. So and the hydrogen H. Okay. And the hydrogen is H. Proton is the H plus, and the hydrogen is H. Now in this effect, that will go to the next effect. That is called the negative effect, negative E effect. So this is the positive E effect, and this is called negative E effect. So what is negative E effect, right? Now, if you ask that what is negative E effect, so what we have seen in the positive E effect, so that means electron is going to that atom where the coming group is where transfer to that atom to which the reagent gets attached. Okay, so reagent is H plus is coming, so that's why the electron density is going to that carbon. Which carbon? Let's say this carbon is going. Now this carbon is attacking. So now the atom which to which the reagent gets attached. So this carbon only reagent get attached, and there is a formation of the positive charge. Now let's say negative effect. Now we'll see the one example, the same example with different kinds of functional group. Suppose we have a this one. So this one means there is a suppose CH3, right? There is a CH3 molecule. CH3, CH3, and this carbon is carbon one is there, another carbon is here. This is also CH3, and this is also CH3. Right. Now we have an electron density. So in this effect, pi electron of the multiple bond transfer to that atom which the attacking region doesn't attach. Okay. Now we have a Cn minus. So there we have a proton means H plus. But here we have a one nucleophile. Nucleophile means a atom or a functional group that contains the negative charge. Now if we have in the reaction mixture, so one is positively charged and one is negatively charged, and your incoming group, let's say this is the incoming group. This is an incoming group. It is coming from outside. So incoming group is the incoming group, and the in situ what it is forming. Let's say here is a minus charge. There is a positive charge. Now we have a two options. So one is negative charge, one is positive charge, and an incoming group is also negative charge. So obviously negative charge cannot go to that carbon where already electron density is there, because there will be some repulsion between electron to electron. So that's why the incoming group depends on the incoming group charge or polarity. It goes to the opposite polarity to that carbon, attacking to the carbon. So now the Cn minus going towards the where the positive charge is there. Now you see what will be the product. So because I am writing, how I can say these things. So I'm drawing all these things now. So that's why the sometimes I remain silent actually. So this is the nucleophile. So it is coming to the electrophile present here. So now after attacking this nucleophile to this carbon, you are generating. So now this positive charge is here. Now negative charge is here. So then it is going to the negative charge. Then we are generating this molecule. So now we have this final molecule is this one. So now let's say we have some positive charge or E plus, because here is a negative charge. Now we have to neutralize this molecule because this molecule is not stable, right? So let's say we have now E plus, right? So now let's say we have a E plus or any electropositive atom. Now it will go and attach to that carbon atom where the negative charge is there. So here is a one positive charge. Now you can see here one E is coming. Now there is a methyl and methyl, and here is also one methyl and also here methyl group. Now you can see the negative effect and the positive effect is also there. Now the question is the when inductive and electromagnetic effect operates in opposite direction, the electromagnetic effect predominates. Now how we will consider suppose in a molecule when inductive effect and the electromagnetic effect operates in opposite direction. Okay, so suppose you have a inductive effect plus I effect and plus E effect in opposite direction. Now the electromagnetic effect actually predominates. Okay, so that's why. So when suppose there will be some question, so in a molecule there will be some inductive effect as well as the electromagnetic effect. So then obviously you have to consider the electromagnetic effect predominantly. Okay, so before I'm going to finish this one, I'll go quickly because during the drawing section, maybe there are some not audible properly. So that's why I'll repeat. Means I'll go quickly. We have 5 6 minutes. So what is resonance effect? So resonance effect is defined as the polarity produced. You can see the polarity produced during the session. The polarity produced in the molecule by the interaction of two pi bonds or a pi bond and a lone pair of electron. So let's say we have this molecule CH2, CHO and NO2. Now there is some tautomerization between this aldehyde group. Then there is a formation of this kind of structural intermediate structure 2. Then structure 2 to structure 3 it is forming here. So I have also drawn it in a big way. So but still I am drawing here. So that's why when I was drawing, so that I was a little bit silent. So the resonance effect, it R effect, mesmeric effect shortly named as the M effect. Okay, so there are also resonance effect. We can also divide in a two way. One is the Plasar effect, that is called positive resonance effect. That is called positive resonance effect, and one is the positive resonance effect. We discussed one example with aniline where the lone pair of electron is coming here and the lone pair again. So there are possibility of the five canonical structure. This is called resonating structure. And again, we come back to the identical molecule or the parent molecule after five structure. So okay, this is called the positive resonance. Why it is positive resonance? Because the electron is going away from the atom attached to the conjugated system. Now we will discuss the what is the negative resonance effect. So in the negative resonance effect means the opposite to the positive resonance effect. So that means the electron coming towards the atom or subsequent group attached to the conjugated system. You can see, so there is a electron movement from the benzene ring or the arene system towards the nitro group because nitro group present here. So that is why so electron is pulling towards itself. Okay, pulling towards itself. So that's why in the aromatic system there is a generation of the positive charge. So the whole process is called as a negative resonance effect. And what kind of group shows the positive R effect and positive negative R effect? So positive R effect, these are the groups will show the positive R effect. So these are the group halogen, OH group, OR group, NH2 group, NHR, NR2, and NH2R. So if you see anywhere in a conjugated system, if you see this kind of group is attached, what is conjugated system? If there will be some alternative double bond, then this is called the conjugated system or any benzene ring. This kind of system also because alternative double bond is present there. So that's why it is called the conjugated system. If you see this kind of system or this kind of system is attached one, uh, what can I say? One these are the groups. Then you can say it will show the Flasser effect. And if you see anywhere this conjugated system attached with this kind of group, so acid group, aldehyde group, ketone group, cyanide group, or nitro group, then it will definitely show the minus R effect. Now it is coming the electromagnetic effect. Like the same way resonance effect also, electromagnetic effect also we can divide it in two ways. So one is the plus E effect and where the plus E effect, what is the plus E effect? So the multiple bond, bi-electrons of the multiple bond are transferred to that atom where the reagent get attached. So let's say there is a pi electron cloud. Like double bond is always like in this way. It always oriented in this way. So electron cloud is above and below. Now the electron cloud is above and below. Now let's say this double bond, the whole electric density is going towards one carbon atom. So let's say then there will be a polarity difference. So one carbon will be positively charged, one carbon will be negatively charged. Now you have in this reaction medium, let's say proton source. Now this proton source will taken up by the negative carbon. Now what will generate? Will generate one positive charge here and one hydrogen atom here, right? So one hydrogen atom is attaching here. Now this is called the plus E effect. Okay. Now it will go to the negative effect. What is minus E effect? So now the minus E effect is the in this effect pi electrons of the multiple bond are transformed to that atom to which the attacking reagent does not attach. Okay. So now the double bond is there. Now the Cl minus is coming here. So now there will be generation of the negative charge. Now if you have a E plus electrophile is there. Now you will generate this kind of molecule where it is called as the negative E effect. But anywhere if you see when the inductive effect and the electromagnetic effect and the inductive effect and the electromagnetic effect operate in opposite direction, the electromagnetic effect is predominates over the inductive effect. Okay, and sorry for the interruption. So because in this lecture somehow I was silent because when I was drawing the structures, because during drawing I cannot speak like this way. So that's why I also repeat this lecture, and also I'll try to give my best in the next lecture. And so today we discuss about what is the resonance effect. There are two resonance effects: plus R effect, minus R effect, and also we have discussed the mesomeric effect, and also the what is the resonance effect, mesomeric effect also same, and also we have discussed electromagnetic effect, where the electromagnetic effect is what the electromagnetic effect. There are also two types of electromagnetic effect is there. One is the class E effect, and one is the negative effect. So okay, so today we'll stop here. Maybe the next section I will come back with some interesting question answer solving, problem solving, and also then maybe we can go to. I have to check whether how much it is left. Then we'll go directly to the reaction and mechanism part, or maybe we can also discuss one or two lecture about the stereochemistry, so that we can quickly go through all the chapters. Okay, thank you.